Endothermic reaction transfers thermal energy to the surrounding, leading to an increase in temperature of the surroundings. Endothermic reaction takes in thermal energy from the surrounding, leading to a decrease in the temperature of surroundings. Exothermic reaction is a reaction that gives out heat. Endothermic reaction is a reaction that takes in heat. Temperature increase, reaction becomes hotter. Temperature decrease, reaction becomes colder. Temperature increase like burning of coal. Temperature decrease like changing solid to liquid and then to gas. So that's why where the reaction takes in heat. Physical process of exothermic changes include condensation, freezing, dissolving of anhydrous salts, dissolving of acids like concentrated acids and alkalines in water, combustion of fuels, respiration, corrosion of metals, neutralization, condensation, freezing, dissolving of anhydrous salts, dissolving of acids and alkalines in water. Endothermic changes physical process is evaporation, boiling, melting, dissolving of some ionic compounds, dissolving of crystalline salts like copper sulfate crystals in water, and that photosynthesis and thermal decomposition like heating of calcium carbonate to form calcium oxide and carbon dioxide, reaction of sodium hydrogen carbonate with dilute acid. Photosynthesis, thermal decomposition like heating of calcium carbonate to form calcium oxide and carbon dioxide, reaction of sodium hydrogen carbonate with dilute acids. The word carbonate, the word ammonium, the word thermal decompositions are endothermic. The transfer of thermal energy during the reaction is known as the enthalpy change. It is measured in kilojoules. The enthalpy change represents the difference in energy content of the reactants and products. So total energy of products minus total energy of reactants. Minimum energy that colliding particles must have to react. A reaction will occur only when the reactant possesses energy equal to or more than their activation energy. A reaction will occur only when the reactant possesses energy equal to or more than their energy activation energy. So reactants produce energy change is negative when exothermic energy change is positive when endothermic. Bond energy is the energy needed to break a bond. Bond breaking is endothermic, takes in energy. Bond formations exothermic give out energy. Now, electrolysis is the breakdown of an ionic compound molten or in aqueous solution by the passage of electricity. Electrode is a rod that allows electric current to pass through. Electrolyte is a molten or aqueous solution that conducts electricity. Electrode is a rod that allows electric current to pass through. Electrolyte is a molten or aqueous solution that conducts electricity. So wires contain free moving electrons to see whether there is electricity. Inert, not reactive element is like carbon, graphite, platinum. Substance cheaper, mysterious. The conditions electrode is firstly inert, secondly free moving ions to conduct electricity, and thirdly it is cheaper. So electrode is inert and there is free moving ions to conduct electricity and cheaper. So it flows from the anode to the cathode. Okay. So conditions of electrode is firstly inert. Secondly, there is free moving ions to conduct electricity and it's cheaper. So, electrode is a rod that allows electric current to pass through. An ionic compound can conduct electricity. And there is one electrolysis element is graphite, metal is platinum. Inside electrolyte is free-moving ions. Matters of hydrogen are formed at the cathode, while no matters other than hydrogen are formed at the anode. And chlorine is greenish yellow gas, bubbles of greenish yellow gas produced. Cathode is gray silvery metal deposit. Anode is bromine gas, it's like bubbles of reddish brown gas release. Cathode is the lead metal deposit, so there is gray metal deposits. Bromine is red brown gas release. Bubbles red brown gas, bubbles green gas release. Hydrogen bubbles of colorless gas release. Why chlorine deposits hydroxide is because ions are more numerous than hydroxide ions, so chlorine ions will be selectively discharged at this anode. So ions are more numerous than hydroxide ions, so chlorine ions selectively discharged at the anode. So hydrogen ions discharge in preference to ions of metals above hydrogen in the relativity series: potassium, sodium, calcium, magnesium, zinc, iron, lead, hydrogen, copper, sulfur. Ions of metal below hydrogen in the series will be discharged during electrolysis. Sulfate, and nitrate ions remain in the solution are not discharged during this electrolysis, while the hydroxide ions give out electrons most readily during this electrolysis to form water and oxygen. Okay, sulfate, nitrate, chlorine, bromine, iodine. Chlorine gas, it will breach the limers paper, and sodium hydroxide left in solution, so solution become alkaline, so red limers to blue. Why chlorine choose instead of hydroxide is, and why hydrogen chosen instead of sodium. So because hydrogen ions are discharged in preference to ions of metals above hydrogen in the relativity series. Hydrogen gas bubbles colorless gas produced. So4OH 减去 O2 加 2H2O 加4E 减 4OH 减去 O2 再加 2H2O 再加4E 减 This is oxygen and water with bubbles of colorless gas. So 4OH minus 2O2 plus 2H2O plus 4E minus. Okay, and there is 2H plus 2E minus 2H2. Copper matter is reddish brown solid deposited. And then there is purification of copper. Intensity of blue color does not change because there is no net loss of copper ions from copper sulfate solution. And okay, so basically, anode electrode dissolve in solution and become smaller. There's a pure copper plate and an impure copper ore. Pure copper plate put in cathode, impure copper ore put in anode. And there's a direct current supply, there's an electron flow, so there's impurities. So the copper, impure copper, is where electrode dissolve in the solution and becomes smaller. And so electrode dissolve in the solution and becomes smaller. And that cathode is red matter deposits on the electrode, so it becomes thicker. Anode is impure. Anode is like electrode dissolve in the solution and becomes smaller, where the impure copper. And copper is the blue of the experiment because no loss of copper ions from copper sulfate solution. Cathode with pure copper is red matter deposits on the electrode, so it becomes thicker. And yeah. There's the way that the pure copper plate is cathode is because those cation ions will give out their electrons. To electroplate with silver is to connect a silver rod to the positive end of the battery using copper wires. Then you clean the surface of the spoon with sandpaper. You put the spoon in a beaker containing silver nitrate solution. You connect the spoon to the negative end of the battery. So firstly, prevent corrosion. Secondly, improve appearance. The silver object to be electroplated is cathode, and the plating material is anode. So silver ions gain electrons to form silver matter. Silver ions gain electrons to form silver matter, and this electrolyte contains some ions as plating material. Silver electrode dissolve to form these silver ions. Ag plus E minus to Ag in the cathode. Advantage of fuel cells is no harmful products. Water is the only product. There is no greenhouse gases, no carbon dioxide. They are efficient and produce more energy per gram of fuel burn. Renewable energy as it can be obtained from electrolysis of water. Disadvantage is it is high cost. The electrodes and membranes are expensive. Manufacturing the fuel cells involve production of toxic byproduct. The hydrogen needed is manufactured from fossil fuels that are non-renewable. And manufacturing the fuel cells involve production of toxic byproducts. And hydrogen is very light and need larger storage. And the precaution is that hydrogen is highly flammable and explosive, so you need to wear fire extinguisher. Hydrogen is very light and it needs larger storage, and hydrogen is highly flammable and explosive, so you need to wear fire extinguisher. Okay, so the formula is 2H2 plus O2 to 2H2O. The chemical reactions occur when particles of the atoms collide. They must collide with a certain minimum speed, otherwise they just bounce off one another. The stronger the collisions, the faster the reaction. Physical change is no new substance are made, easily reversed. Chemical change, new substance are made, not easily reversed. Adding iron to sulfur to form a mixture can be separated with magnet, melting, boiling, freezing. Heating iron with sulfur to form iron sulfide and baking again. So factors is temperature. Increasing temperature increase the rate of reaction because particles gain more kinetic energy, move faster, collide faster, and more of the molecules have energy greater than activation energy. So kinetic energy of particles increase, more frequency of collisions, and more or higher percentage of particles have energy greater than activation energy. Increasing pressure of gas is because particles are closer to each other, so more collisions. And crushing a solid using small pieces increase because larger surface area, so more particles collide at the same time. Okay, greater surface area of zinc, frequency of collisions between zinc and acid particles increase. Using more concentrated solutions because more particles per unit volume collide at the same time. More particles per unit volume or particles closer together increase the rate of collisions. Catalysts increase the rate of reaction because the catalyst provides an alternative pathway for the reaction that lowers the activation energy. Catalyst providing an alternative reaction pathway with lower activation energy. This means a higher proportion of reactive particles have energy greater than the activation energy and will result in more successful collisions per second. So provide alternative reaction pathway with a lower activation energy. A higher proportion of reactive particles have energy greater than the activation energy and will result in more successful collisions per second. Okay, and there is ionic equations. Okay. The volume of gas per minute measured using a gas syringe, the drawing, and at the beginning, reaction is fast because small particles are colliding. Rate slows down and becomes zero because reactants are being used up, so less collision. Increase in rate in experiment 2 may be due to the higher temperature, higher pressure, crushing the solid, higher concentration use of better catalyst. Sulfur dioxide gas is toxic and will dissolve in water. There is precaution error, difficult to see the cause, difficult to determine the endpoint or it disappears. Start-crop reaction time is slow. Start-crop immediately after adding hydrochloric acid. The higher the temperature, the shorter time taken for the cross to disappear, and the higher the concentration, the shorter time taken for cross to disappear too. Na2S2O3 plus 2HCl to 2NaCl plus H2O plus SO2 plus S. NaOSO3 加 2HCl 去 2NaCl 加 H2O 加 SO2 加 S Na2S2O3。Reversible reactions are reactions that go both forward and backward without going to completion. Hemo process N2 加 3H2 or NH3. How to make sure all the water has been removed? Repeat the process of heating, cooling, and waking until a constant mass is obtained. Heat the hydrated crystals in a test to collect the liquid produced during heating. Stop the heating when the color changes and test the liquid boiling point. If it boils at 100-degree, water is formed. Pour the water back at the anhydrous crystals, the color will change again. There's heat the hydrated crystals in a test tube, collect the liquid produced during heating. Stop the heating when the color changes. Test the liquid boiling point. If it boils at 100-degree, the water is formed. And pour the water back to anhydrous crystals, the color will change again. CuSO4.5H2O to CuSO4 plus 5H2O. Hydrated copper sulfate and hydrous copper sulfate. Okay, hydrated copper sulfate is pink and anhydrous is blue. Hydrated copper sulfate is blue and anhydrous copper sulfate is white. NH4Cl to NH3 plus HCl. NH4Cl converts back into NH3 and HCl gases when heated. And there is dynamic equilibrium. Rate of forward reaction equals rate of backward reaction. Concentration of reactants and concentration of products remain the same, stay at a constant. Brown gas and colorless gas. Nitrogen dioxide is brown gas. N2O4 is colorless gas. This Chandler principle states that if a system in dynamic equilibrium is subjected to a change, the position of equilibrium shift in the direction that reduces the change. If a system in dynamic equilibrium is subjected to a change, the position of equilibrium shift in the direction that reduces the change. So equilibrium may change by temperature, pressure, concentration. Increasing pressure forces the reaction to go to the side that has less number of moles. Increasing pressure will shift the equilibrium to the right to give less number of moles so more ammonia is formed. If pressure is too high, the process will be too expensive, so it's used at 200 atm. Increasing temperature forces the reaction to go to the side that is endothermic to use up the excess heat. So if it is exothermic, increasing the temperature shifts the equilibrium to the left and less ammonia is formed, but rate of reaction is faster, so equilibrium is reached in the less time. Rate of reaction is faster, so equilibrium is reached in less time. So the above reaction is performed 450. Yeah. Increasing temperature favors forward reaction, which is endothermic to use up the excess heat. Equilibrium shifts to the right because forward reaction is endothermic, so there's more hydrogen and iron zinc will be formed. Adding more reactants or removing ammonia favors forward reaction and shift the equilibrium to the right to form more ammonia. Adding more ammonia, removing nitrogen or hydrogen shift the equilibrium to left, favor backward reaction, ammonia dissociate, creating more nitrogen and hydrogen. Endogenous H2 to 2NH3. Nitrogen is fractional distillations of liquid air, and hydrogen is from methane or natural gas. Nitrogen from the air, hydrogen from natural gas, 450 degree, 200 atm ion catalyst, and nitrogen and hydrogen mixed in proportion 1 to 3 by volume mixture of gases compressed 20,000 kPa. Heated to 450 as catalyst, as determining only about 10 to 50% nitrogen and hydrogen converted to ammonia. A mixture of ammonia, nitrogen, and hydrogen is obtained. The mixture of gases is cooled. Okay. Ammonia gas and condenses to form liquid ammonia, and reacted nitrogen and hydrogen are pumped back into the converter for further reaction. The lower the temperature, the higher the yield of ammonia, because the forward reaction is exothermic. The higher the pressure, higher yield of ammonia, higher pressure increases the speed of reaction. Lower temperature also results in a slower reaction. Despite conditions like high pressure, so a catalyst is also used to speed up. SO2 加 O2 去 OSO3 450 degree, ADM vanadium B oxide. Okay. Vanadium B oxide. Source of is burning of sulfide ores, roasting of sulfide ores in air, burning of sulfur. Okay. So sulfur burns in air to produce sulfur dioxide. Sulfur dioxide and oxygens are heated to 450 degree and passed over vanadium B oxide. Sulfur burns in air to produce sulfur dioxide, and sulfur dioxide and oxygen are heated to 450 degree and passed over vanadium B oxide. Vanadium B oxide acts as a catalyst in the reaction. The reaction is three. Then sulfur burns in air to produce sulfur dioxide, and sulfur dioxide and oxygen are heated to 450 degree and pass over vanadium B oxide. Vanadium B oxide acts as catalyst in the reaction. The reaction is exothermic. A mixture of sulfur dioxide and sulfur trioxide is obtained. Sulfur trioxide is used in the production of sulfuric acid. It is dissolved in concentrated sulfuric acid to form oil. Oil is diluted with water to form sulfuric acid. And the sulfur dioxide is cooled and passed in converter for further reaction.